So let's go over how to create a thread in Python. So what is a thread? A thread is a separate flow of execution. It is one set of operation that needs to happen. So let's break it down into pieces, right? Your computer has a thing called a central processing unit, or you usually hear the word CPU. A CPU can come with many cores. It can be 4, 8, 16. Computers are getting better and better. Hardware is getting better and better. But in this example, I'm going to use a 4-core CPU. Each core can execute a task, and the amount of cores signify the amount of tasks it can run in parallel. So if a computer only had 1 core, that means it can only do 1 task at a time. But since this CPU has 4 cores, that means it can do 4 tasks at the same time, because each core will be doing 1 task. And in the case there's 8 cores, it can run 8 tasks at the same time. So the more cores, the better, right? Because that means more tasks can be done at the same time. So in this example, each task can be considered a thread, a separate flow of execution. And as you can see, I applied a thread to each individual core. So if there are multiple threads communicating with a single core, through communication, one thread will execute while the others wait. So for example, core number 4 has 2 threads. All right, so the first thread will run, and then once that's done, it'll run the next thread, right? Through communication, through best practice, it'll run one thread and then inform the next thread when it's ready to run. You also have instances where a thread waits for an event to occur, which will never happen, right? And that is considered a hanging thread, which is not good. We don't want a core to be waiting and waiting and waiting, and it never actually executes. So now you have a core that's useless. You have a hanging thread. Using threading can help make a cleaner and easier design. So now that we got an understanding of what a thread is and how it's utilized in a CPU, for example, let's continue on. Let's see how we can create a thread utilizing Python. Alright, so I'm in my favorite editor, Visual Studio Code. You don't have to use Visual Studio Code, it's just what I prefer. And I already created my Python file called threads.py. I have the console open so that I can run it when I need to. And now we are ready to create a thread using Python. So how do we create a thread in Python? Well, we utilize Python standard library. And the standard library is called threading. So all we got to do is import threading and create a thread instance. Now that's just a lot of words, so let's actually execute. So the first thing I'm going to do is I'm going to import threading, and like I said, it is a standard library that Python provides to actually create a thread. And I'm also going to import another library called time, because I'm going to use time to delay the execution for a little bit so that we can see the power of a thread. And now I'm going to create a variable to hold that instance of a thread. So I'm going to call it x, because a thread is just an execution of an operation. And I'm going to set that equal to an instance of a thread. So threading.thread, and what this is going to expect is going to expect a target, and this target is simply going to be what is ran, and it's going to be a function. So I'm going to create a function really quick, and I'm going to do def say my name, and what this function is going to do is once it's ran, it's going to say the name that was provided. So I'm going to expect a name parameter, and I'm going to print out hi, my name is, and it's going to be the name that the user passes, or whatever passes to this function. And then I'm going to utilize time, and I'm going to sleep for 3 seconds just so that we can see that it printed out this prompt, and it's going to delay the function for a little bit, and then it's going to run this next print, which is going to be hi, my name is, and it's going to be the same name. Cool. So this is going to be what the thread is going to run once, and we're going to specify that by specifying it as the target and make it equal to the name of the function, which is going to be say my name. Now it is expecting an argument, it is expecting a parameter, so we got to pass this name. So how we can do that is we just put a comma here, put args, and we're going to specify a tuple with all of the arguments that this function is expected to have when it runs this, thread. So I just expect one argument, so it's going to be called geo for my name, and I'm going to use capital G, respect. And it's a tuple, so it has to be a comma. Even if there's only one within the tuple, you still got to end it off with a comma, just to let Python know that it is a tuple. All right, cool. So now you have a thread, right? It's an instance of a thread. Its target is this function right here, which is going to say hi, my name is, with the name that is passed as an argument. It's going to sleep for 3 seconds, or how many seconds you put. It could be 5, it could be 100, but in my case, I'm just going to put 3. And then to end off this thread, we're going to print out by my name is with the same name. And we create this instance that's being held in this variable of x. The target is say my name, which is the function, and the args is my name that I pass as a tuple. Now to actually run the thread, you just got to do x.start and open up parentheses, and we're good to go. So let's run this. Let's save it and run it. So Python threads.py, or whatever you named it. Run it. You see hi, my name is geo. It waited a couple seconds and it said bye, my name is geo. So that's a single operation that is ran on a thread. Pretty cool stuff. Now you know how to run a single thread. So how can we see the amount of active threads when running this simple Python file, right? We know we created a thread, and we know we started it, and we know that it's running this say my name function on a thread. But how can we see the amount of active threads? Well, funny enough, or greatly enough, if that's a word, threading comes with an active count of the threads that are running. So we can do threading.activeCount and open that up, and we can print it out to see the amount of threads that are being ran. So let's run that again, and it seems like it's deprecated, so actually it's supposed to be active underscore count. Let's run that again. Say hi, my name is, and it's still going to run 2 and then by my name is. So you're probably wondering how does that happen, right? How is it saying hi, my name is, and I thought we delayed it, and then how is it doing that in between the thread, right? And why is it saying 2? Well, remember there is a main thread. That's the actual execution of everything, right? A thread is running this Python file, while internally within the Python file we created another thread to run this say my name operation, or this function. So that's why we see hi, my name is, because first that main thread is being ran to actually run this Python file. It's going to go and create another thread to run this say my name, right? It's going to print this out, it's going to sleep, but then that same main thread is going to go on to the next line, which is printing out the active count, which in this case is going to be the main thread now, and the thread that we just created, which 1 + 1 = 2. That we learned that in elementary school, but yes, 1 + 1 = 2. So now there's 2 threads, and then after 3 seconds it's going to print out by my name is. So cool, we have the main thread and we have the thread that we just spin up. So in total that's 2 threads. So the cool thing about threads is the communication. If a thread is waiting for anything external or is sleeping, it's normal to switch to another thread to execute the task, then switching over either back to the previous thread or another thread entirely. So we saw that, right? We saw that it's able to run this the main thread is able to then spin up another thread, run that thread, and then go back to the main thread to print out the active count, and then go back to the thread that was spinned up to print out the by my name is. And if you have multiple cores, you may not even have to switch. It can be ran in parallel. But it's all happening so fast. This give it a parallel feel, even if it's not actually running in parallel. If you have multiple cores that are running threads simultaneously, then you have parallelism. But the amount of efficiency there is running multiple threads on one core is a thing of beauty. So let's see this in action. Let's actually create multiple threads. We could do that. So I'm going to copy this, and I'm going to say my name again. And I'm just going to change the prompt a little bit and say hi, my name again is, and by my name again is, just to see the difference. And we're still going to keep the same sleep time, But now we're going to use this function to be ran on another thread. And what we're going to do to run multiple threads is we're going to create a for loop to spin up multiple threads and then start it. So just to see the uniqueness of each prompt, what I'm going to do is I'm going to pass in an index for each execution of the function. So say my name again function is going to get index, as well as say my name is going to get index. And what I'm going to do is I'm going to print the index with the prompt. And now I'm going to create a for loop to create an index to pass with each spin up of a new thread. So for index in range, and I'm going to just do 5, I'm going to create a thread and I'm going to start it, but I have to pass in this new argument. So it's going to be index, and I'm going to create another for loop, but now it's going to be with say my name again. And change up the name as well, so with Geo. And so what it's going to do is, and I'll take this out or comment it out. What it's going to do is it's going to run through this 5 times, right? It's going to spin up 5 threads for say my name. It's going to pass the name as well as the index, and it's going to start it 5 times, as well as say my name again with a new name and a new index, and it's going to start each one 5 times. Now, what I just said is the ability for threads to communicate and to work together, to run one, switch over to another one and run it, switch over to another one and run it, is a thing of beauty. So now we'll be able to see that in action. So let me clear this out, and let me just run it. Python threading.py or whatever you named it, run it, and boom, we can see that it's starting up as usual, but it's being returned in a different order. Because remember, it sleeps, each of them sleep for 3 seconds, and then it prints out the final statement. But as we see, it started off fine in order, 0 through 4 for the initial thread, right? It's going through this for loop, it's starting each thread, and it's printing it out as expected, right? And even for the second version of this thread, right, we created 5 threads for this new function right here, and it's in order as well. But when it's being returned, it's being returned out of order, right? We have no control over that, right? It's printing out by my name is Geo for the first one, but then it, instead of going to 1, it goes to 2. But then and then for the second thread that we created for say my name again, it's printing out the second one, which is, you know, because index starts at 0, but it's printing out the second one and then the third one, but then now it's going back and printing out the fourth one in this case, and it's all out of whack. But because it's just going to print out whatever is available first. So the tough part about threads is knowing which thread will execute next, especially in cases where there are thousands of threads. Threads are scheduled and allocated by the CPU by using the thread scheduler, which you cannot control. So that's something to keep in mind. Like, yes, you have threads that are running its own execution, its own operation, but when it comes to controlling threads, you don't have the ability to. The thread scheduler does all that work, all the communication, all the switching, and whatever is available first gets that, right? Or whatever the thread scheduler chooses gets that opportunity to run the operation. So that's the tough part. Yes, you're able to run thousands of threads, but whoever goes first and whatever gets ran when, that's not up to us. So yes, it's able to run as expected, and it got to the end and it ran all the operations, but in what order? Not exactly sure. So there are different types of threads, right? And the thread that I want to talk about next is the daemon thread. You probably know or heard of the word daemon, right? So a daemon is a process that runs in the background. If you have a computer right now, which I'm pretty sure you're on, or even if you're using a computer, so there are different types of threads. And another thread that I want to talk about is the daemon thread, right? And you probably heard of the word daemon before, but just in case you haven't, a daemon is a process that runs in the background. So right now, even if you're using a cell phone or if you're using a computer, there are things that are running in the background that you don't even know about, right? So things that keep track of updates or apps that might be pinging a server to see if it's active. There are a lot of things that are working in the background, and companies utilize threads to do that in the background without you even knowing. But in this case, a daemon thread was shut down immediately when a program exits. So if a program is running threads that are not daemons, then the program will wait for those threads to complete before it even terminates. So we saw with the say my name example that each thread ran no matter what. Even if it got to the last line of the file, it waited for those threads to finish before actually ending the execution of the Python file. But in the case of a daemon thread, it will not wait. It will just exit the program. Threads that are daemons are just killed whenever they are at the exit of the program. So depending on the type of behavior you want, if you want to wait for all the threads to finish executing, do not make it a daemon thread. If you do, make it a daemon. So let's see how to make a daemon thread. So what we're going to do is, I'm still going to have this say my name function, and I'm going to utilize that for the thread, and I'm going to have x equal to the instance of the thread, so threading.thread, and then the target is just going to be say my name for all my Beyonce fans and Eminem fans. And then for the arguments, I'm just going to make that equal to geo, and remember it's a tuple, so put a comma at the end, and I'm going to do x dot start. Now the only real difference, right, this looks exactly how we started before, but to make it a daemon thread, the only difference is we just got to put a comma at the end here and utilize the word daemon, which we see here, it pops up automatically for us, and set that equal to true. By default, obviously it's false, but if you want it to be a daemon thread, then you just make it true. Now let me clear this out and let's see the difference, right? So let's do Python and let's run the threads.py file. And as you can see, the program exit, right? It runs the initial, hi, my name is Geo in this case, and then it just exit the program. It doesn't even wait for the by my name is, right? Because if you guys remember before, the ones that weren't daemon threads, they would wait for the sleep to finish and then print out the last line of this function. But because this is a daemon thread, it is not going to wait for it. It's just going to kill the program, because after it finished starting, yes, it had enough time to run this initial line of print, hi, my name is, but it doesn't have enough time to do anything else, because after this start, it is the end of the program. There's nothing else to run, so it's just going to kill the whole program. So if that's the type of behavior that you want with your threads, then go for it. But if you actually want to wait for the execution of your threads, do not use daemon threads. And we can see that if we give it some time, so if I do time.sleep and I do, let's do 10 seconds, right? And I run it again, we can see, okay, it waited 3 seconds and it's still waiting, right? Because right here it's for 10 seconds, while here there's only a 3-second delay. So there is enough time to execute this last line and then some, right? And we can see that it got to that last line and it waited for a couple more seconds before actually killing the program. So if you know that your program is going to be running longer than the thread that you're trying to run, go for it. But like I said, we don't get to control when a thread is being ran, so it's a little bit dangerous. So remember the behavior for the type of threads that you want to execute. Now if you want to force it to wait, there is a method that we can use, and that is the join, right? So we can do x.join. So in cases of threads that you want to wait until it's done, even if it's a daemon, we can use this, right? It will wait for this thread to finish before actually ending the program. So we can actually save that and clear this out, and we can see that it works. So let me do Python thread.py, and as you can see, it didn't exit off automatically. It actually let it finish executing the thread and then it killed the program. So we could do that. You could do x.join, or you could do whatever variable that's holding your thread instance and .join, and it will wait for that thread to finish executing before it exits out of the program. That is how you create threads in Python. There's the regular threads, which will wait for your threads to finish executing, and it will run whatever function that you provide, as well as whatever arguments that you provide with that function. Then we learned about daemon threads, which will not wait for your thread to execute Once it gets to the end of the program, it will stop. Unless we use the .join, which will then wait for that instance of that thread to finish before exiting the program. So there are a lot of use cases for threads. Threads are used in your web browser to handle downloading files or dealing with many open tabs. Threads are used on web servers to handle many requests that are hitting the application. Like I said before, if you're using a computer or a phone, most likely there are threads being used as I speak, right? That thread is used to maybe download some updates or constantly pinging a web server in the background, or even a thread to maintain the fact that it's running in the background. There's a lot of use cases for a thread, and this is just a nice beginner introduction to it. In the next video regarding threads, I'll go over the thread pool executor, which is great for grouping and executing threads together. This will provide a better way of showing real life examples. So until then, go ahead and leave a like, subscribe, and if you have any questions, leave it down below. Thanks for watching.